Thank you, Shri. Many of you will be aware that we have an issue in cities, and that we're building a lot of city. Especially if you attended yesterday's event, this was also mentioned uh, quite at length. So one example of this is that the mass of our built environments now exceeds the mass of the living biosphere, and in the next 15 years, this is set to double if we don't change anything about it. So one approach to alleviate this is circular economy, and then specifically in circular future cities, we are looking at circular economy in construction, and the main goal there is retain existing value or do not throw away the value you have. So avoid extraction, avoid waste. So it's straightforward to argue that we need circular future cities, but what are they? They won't be the literal representation you see on the left, but then what are the characteristics? What comes together? Where will circular practices take off? So in that sense, one of the things we ask about at a general sense is what does a circular future city do differently? And one aspect of that, an important aspect, is governance and using catalysts for the emergence of circular economy. So we're talking about a shift in governance where there is an understanding of the material resources and the other values in the built environment that guides, in a way, the urban harvesting of resources. So we're talking more about a planability or steerability of the resource wealth in our cities. There's two aspects that are important to this. One is monitoring this resource landscape, so mapping materials, but also regulating impact. The other aspect is enabling economic agents. It's, of course, an economy. It needs to run by itself. So there's an aspect of incentivizing markets, but also informing designers, for example, as agents to create structures that have more value that can be retained for longer. Of course, within the the SCL Global program, we're looking at new technologies and how that can help understand the circular economy of construction. And three aspects there are particularly important. One is mapping stocks, flows, and yields, as I already mentioned, but also evaluating built assets in terms of circular economy objectives. So not just in terms of money or not just in terms of carbon, but how do things work in this flow of resources? Finally, it's also important to look into how can we trade, because we're talking about an economy. So how can we trade future building information is important. Buildings are particularly um, difficult because the value, the materials come out maybe 100 years from now. So, and the information that's tied to these materials, to these buildings, strongly influences the value we give to it. So, how can we bring that future information into the present is another technological question that we have proposed solutions for. Finally, these are intricate topics with, about systems of systems. So there's a need for integrated socio-technical solutions and tangible platforms to explore this new knowledge.
Okay, so now it's my turn to tell you a bit more about the research that we have done in our module. So let me start with different examples of how we can map material stocks. And the first example has to do with energy performance certificates. So this is a kind of data source that we have plenty of in Switzerland for thousands of buildings. So then we're able to extract material information from these building certificates. So here, for example, you see a building, concrete building, somewhere in Switzerland, and we were able to extract information about the main material type and also the um, size of insulation. And then this combined with architectural knowledge enables us to study how much material there is in different types of buildings and analyze that in the context of well, how building characteristics can influence the material composition in these buildings, both spatial spatial patterns, temporal patterns, also other types of characteristics. Another example, again, mapping material stock, is in Singapore. So in Singapore, unfortunately, we don't have as much information on materials in buildings. But then for the few building instances that we had, we were able to develop a parametric model, parametric archetypes that then exploit some similarities between buildings to be able to extrapolate material information to the level of the entire country. And then this allows to quantify information, for example, on amount of concrete or steel. One more example of how we can map material stock is has been performed on different cities. Here you can see Cape Town, Zurich, New York, Tokyo. And what we exploited here is Google Street View data. So when you walk around on the street, you see building facades, you're able to see what kind of material is out there on the facade, how many windows are there, size of windows. So this model exploits computer vision to use this street view imagery to analyze material information from facades. Also building features like style and state, so like for example, deterioration level. We're actually now working on combining this with the other model, because one gives us information what's inside of the building wall, and this one gives us information on the outside. So that's work in progress still. Oops, sorry. Yes, another aspect of our research concerns trading information. So, as Peter has mentioned, we need to enable actors to exchange this information effectively. So we might know what's inside of our buildings. We might know about like what kind of materials is available, but you still have to exchange this information to manage it, to store it. So this research has explored the centralized data marketplace. Um, so how decentralized system could be more efficient way of handling this kind of information. Here, information such as material passports was also investigated, and yes, this is a bit more theoretical aspect of our research, but I think it's extremely important as well to not forget about this aspect, right? Then, when it comes to different actors that we have, we also want to inform designers on which kinds of circular economy objectives are out there. And depending on the circular economy objective, which here we highlighted three: longevity, reusability, transformability. So these three might be important to a different extent to different designers. So we have created this framework that explores the links between the objectives and the design strategies, and then the methods that can be used to explore these. And then one application of this framework that we also explored. Oops, why doesn't it work? Yes, it's built afterlife. Sorry. So built afterlife is an example. Why doesn't it run? Yeah, it runs now. Sorry. It's a QR code that you can scan. It's also visible on the tablet that we have on our module table. And this basically allows you to explore these different objectives and explore the, for example, longevity. So how lifetime extension can be important to you as a designer. What are the methods that you could apply in your work? Next example, also related to actors, is, well, we cannot take for granted that just because we're applying a circularity strategy, that it will be beneficial for the environment. So this is example of research that has explored the impacts of material use. In this case, it was a reuse of concrete, and how different parameters of concrete reuse can influence environmental performance. So again, you have a tool that you can scan the QR code, explore the tool to see how these different parameters, like the depth of cutting, the transportation distances of these concrete components, how all of this will impact the environmental performance of this. And then last but definitely not least, we have this example of visualization of our research findings in this greenhouse gas GAG app. So the idea behind this, here you have an example for Zurich and then for Singapore, how this 3D model of the city is connected with the carbon information behind these buildings. So for circular future cities, how we can implement this in the future, how it could actually look like. And then you have also a chatbot that you can use to ask, for example, okay, I have this information here, how do they interpret it? So it really helps to understand, to give some more context to these results. And let me hand over.
Okay, so that was a short overview of the technological outcomes of the Circular Future Cities module. But of course, we also need to bring it back to the importance of governance. And so throughout the module, we have been dialoguing about pathways to circular future cities with various stakeholders. So some of the things that have been going on in the last months, because of course this is what we're currently focusing on, is, for example, in July we had a special session at the ISAE 2025 about policy and paradigms. We're putting the finishing touches on our synthesis paper, which looks at the type of technological innovations that typically come up in, like, circular future cities related research, ours, but also others, and putting this in a governance framework. And also we will have a final session in our advisory board series, which looks specifically at how can we translate some of our outcomes into formats that are more useful to industry and governance. Thank you.
Thank you, Peter and Camilla. I will continue with the presentations first, and then we will move on to the discussions and question and answer session later, so that the flow can be kept consistent. So we will now go on to our next presentation, which would be a recorded video presentation by Professor Arno Schluter about the Powering the City module. Yeah.
Good morning. I'm happy to present to you some of the key insights of our Powering the City module at the Future Cities Lab Global. Unfortunately, I'm not live with you today, but just a recording, but I hope you still bear with me for the next 10 minutes. Urban areas house the majority of the global population, consume 80% of global energy and global greenhouse gas emissions. The top 100 urban areas alone account for 18% of global greenhouse gas emissions. As we can see on the graphics to the left, buildings contribute to these emissions to a large extent, and one way to decarbonize is through renewable energy production. What we can observe is that globally, municipalities are increasingly directing and incentivizing the decarbonization through renewable power and heating. One way to increase renewable energy production on the urban scale is what we call urban photovoltaics. The placement of PV modules on rooftops is commonplace and viable. We see this in Singapore, in Zurich, in many places. We are especially interested in what is called building integrated photovoltaics, BIPV, which closely merges energy production with building and infrastructure services. Different than standalone PV, BIPV is a PV module and a construction product together. Urban photovoltaics is a field that addresses the complex interactions that occur when integrating PV and BIPV in the urban environment, as we can see on the image to the right. This addresses questions of available surfaces, interactions with urban elements, but also how to utilize electricity produced most effectively. As a module, we work interdisciplinary across different institutions and domains. Our work on UPV can be condensed in 6 research questions: how to scale, novel methods for estimating urban PV potentials, how to utilize, UPV in electric mobility, so how to use the produced electricity the best, how to assess, questions of life cycle perspectives, how to implement, we looked at application case studies in Zurich and in Singapore, how to plan, how to combine different dimensions of planning, for urban photovoltaics. And finally, how to design, which toolsets can support designers, engineers, and decision makers to plan and design urban photovoltaics. In the following, I'd like to highlight the most important findings on those questions. On the question of how to scale, the challenge is that the current simulation approaches neglect these complex urban effects as introduced, such as partial shading, and that impacts PV systems design and yield estimations. What we can see of developing a new generation of modeling techniques and models is that even when we look at this closely, UPV holds significant potential for transforming cities into energy producers. However, this transformation requires careful consideration of matching technology choice and urban characteristics. And the realistic estimation of yields of solar energy production requires the balancing of modeling resolution, so what I'm essentially looking at from cell to the city, with model complexity, the data inputs necessary and available, and the desired output of my analysis. On the question of how to utilize, we asked, can excess solar energy production through PV be harnessed using electric vehicles? Of course, we have times of the day and where the sun is shining very strongly and we can produce electricity better than other parts of the day. And the question is, can we have a dynamic storage through electric vehicles? And the findings confirm that EVs can function as mobile distributed storage, enabling spatial and temporal balancing of intermittent solar PV generation and demand. And what we can also show, and this is shown in the image to the right, that the coordinated planning of PV deployment with smart EV charging and discharging could enhance grid stability and increases renewable energy utilization in cities. To the right, you see these famous images of the so-called duck curve, the difference between the supply of photovoltaics and the demand. And we can see that through EVs as storage, this difference can be mitigated. The question of how to assess, we looked at the key determinants for ecological sustainability of PV, and we can show that the life cycle impact depends strongly on the choice of PV materials, so the cell type, as we can see on the graphics to the top right, on the production location and the installation context. And when we look at case studies, we can see that the carbon emissions of a BIPV system differs up to 19%, depending on also the assembly locations of the modules. So dependent if you take modules from Europe versus China, for example. An important factor is the irradiation threshold, so the amount of radiation received on a surface that determines essentially if a BIPV product is sustainable, and that depends on the grid context. We can see that in Singapore, already surfaces above 300 kilowatt hours per square meter are environmentally beneficial, versus in Switzerland, it's only surfaces above 700 kilowatt hours per square meter. On the question of how to implement, we looked at one very specific typology in Singapore, HDB settlements, which are interesting for thinking about large-scale, sustainable, and cost-effective deployment. And we analyzed the different HDB typologies, and we could see that certain typologies actually can be utilized rather well and allow to produce more electricity on the facade than on the rooftop. Of course, they have a lot more surface on the facade available. And we looked together with industry partners into BIPV designs, lightweight, fast mounting, and angled designs that fit specifically to the context of Singapore and an HDB context. And we could show that this is environmentally beneficial to produce electricity on the facades with these type of photovoltaic modules. But of course, there is certain challenges in terms of fire safety and, of course, economic constraints that might play into this. On how to plan, we combined different dimensions of planning to address socioeconomic barriers, and the colleagues developed a three-layer framework combining spatial, investment, and operational planning that facilitates these interactions to discover and identify those interactions. And one novel form of utilizing solar electricity is especially interesting, the peer-to-peer electricity trading, where different generators of electricity trade electricity amongst each other. And we can show that community-based solar sharing can reduce storage needs of up to 35% and achieve lower energy costs and CO2 emissions as compared to a centralized organization. On how to design, finally, we looked at the design chain, the tool chain that we have from early design until the systems integration. You see this on the top image here. And we were able to tap into existing frameworks such as the City Energy Analyst or Bombix that have been developed among our groups. But we were able to complement this with new approaches. And what is especially interesting is AI-driven and data-driven tools that allow to simplify yield estimation, reduce modeling effort, and also allow to expand the design space, for example, through automated generation of PV design variants or automated yield estimation. And what we can see and what we believe is that the planning of UPV can greatly benefit from these type of tool sets to become more faster, more explorative, and potentially also create more innovative ideas for VIPV in urban settings. Over the duration of the module, we exchange with stakeholders such as governmental agencies, industry, and researchers in Singapore. We intensely discussed the different challenges for UPV for the upscale of BPV in a Singaporean context. From a procedural and institutional level, we observe that BIPV dissolves the traditional boundary between building envelope and energy generation, which creates uncertainty in roles, responsibilities, and procedures. Even more so, it requires interdisciplinary collaboration and integration from design to realization. From the technical and economic level, we observe higher upfront costs due to custom and non-standardized solutions and more complex installation and maintenance processes. And of course, as compared to horizontal PV, there is total lower electricity yields on vertical facades. However, the abundance of vertical facades still creates an interesting solar generation potential. We see a lack of standardized components, which limits scalability and cost reduction. However, advanced manufacturing prefabrication could mitigate some of those cost penalties and simplify installation. Finally, from an environmental perspective, there's uncertainty over the impact of large-scale PV in cities on the urban microclimate, specifically on urban heat. Current studies show both potential heating and partial cooling effects, and currently we follow up on this question and our module in our lab in Zurich, where we've installed full-scale BIPV facade in our climate lab with an artificial sun, and we experimentally explore thermal effects on the building through the facade as well as in the urban environment through measurement sequences in full scale. I'd like to close with an acknowledgement of the entire Powering the City team, of course, our co-investigators, co-PIs, Francis Lee, Markus Schlepfer, Alexander Holberg, Yuming Fu, and Tianfu Singh, our module coordinator, Christoph Weibel, and of course, the entire research team for their tireless work and efforts, and I think some very interesting results. Thank you very much.
So again, my talk is titled One North and Beyond District Models for Future Cities. Cities everywhere, as we know, are searching for new ways to remain livable under conditions of climate change, rapid densification, and economic transition. Our research directly addresses these urgent questions. Okay, now we're in business. I will begin with an overview of the Dense and Green Cities research conducted in the last phase of our program. So with last phase, I mean the whole 15 years that the FCL program has been around. I will then turn to one of our most detailed Singapore case studies, the One North Innovation District, which serves as an exemplar for the other cases. So again, we did a lot more work, but I thought I'd pick one of them to illustrate a bit the kind of work that we did. The main part of my presentation builds on a recent policy paper we published in the International Journal on Smart and Sustainable Cities, titled Integrated Innovation Districts in the Tropics, a Policy Perspective on One North Singapore. We took a policy angle because research only makes a lasting impact when it shapes planning codes, governance, and the way decisions are made. By framing it this way, our findings do not just stay in academia, they connect directly to practice and future development strategies. Over the last 5 years, the Dense and Green Cities project investigated sustainable integrated districts, as we call them, or SIDs,
as a model for high-density, high-livability urban development. Our central question was straightforward, but also challenging. How can dense urban districts integrate ecological, spatial, social, environmental, and economic systems in ways that measurably improve livability and sustainability? We approach this in three ways: comparative case studies in Singapore, Europe, and North America, a mix of methods: spatial analytics, environmental and ecological modeling, social and economic performance assessments, behavioral surveys, and policy analysis, and the development of metrics to evaluate performance across 5 dimensions: spatial, social, ecological, environmental, and economic. Underlying this is the conviction that the district is the right scale for research, large enough to capture complex interactions, yet compact enough to test strategies and measure outcomes. Hang on, I'm stuck here. Across our module, we studied 7 districts. In Singapore, these were One North, Jurong Lake District, and Punggol Digital District. Internationally, we looked at King's Cross in London, Zuidas in Amsterdam, and Quayside in Toronto. And in Zurich, under the leadership of my colleague, Professor Sascha Menz, who's sitting there, we studied Altstetten-Albisrieden, an evolving district that illustrates densification and ecological integration in the Swiss context. For each case study, we applied a consistent methodology: spatial performance, which means spatial network analysis, people counting experiments, and 360 scene analysis to measure connectivity at the human scale. Social performance, GPS traces, co-location-based community mapping, and vibrancy hotspots derived from POI data and stay patterns. Environmental performance, district-scale microclimate surveys, shade mapping, and simulations to assess thermal comfort across the district. Ecological performance, analysis of blue-green infrastructure connectivity, benchmarked with the Singapore Index, combined with NParks datasets and field transects. Economic performance, analysis of knowledge spillovers and amenity pull through mobility and co-location data, digital twins and simulation, BIM and GIS models, Unreal and Unity engines, and VR, AR tools for policy sandboxing, and for policy and governance, document tracing and expert interviews to understand instruments, timelines, and cross-agency coordination. I will not go into detail with all of this, obviously, today because we're pressed of time. But what I want to highlight is that our strength lies in combining spatial, environmental, social, ecological, and economic dimensions, giving us an unusually comprehensive evidence base. For those interested in the deeper methods, I invite you to explore the exhibition and our various publications. So I will come back to this at the end of the presentation. So why focus on One North? It was one of the earliest innovation districts in the tropics, initiated in 2001. Unlike earlier business parks, it was designed from the outset as an integrated district combining housing, work, and leisure. At 200 hectares, it is large enough to capture complex dynamics, but still manageable for research scale. And crucially, it has been under development for more than 2 decades, allowing us to study both planning intentions and lived outcomes. For these reasons, One North became one of our most detailed Singapore case studies. The central image illustrates the ground coverage of One North in relation to its wider urban context, showing how density and open space are distributed. The image on the right breaks the district into precincts and land parcels, which is critical for understanding how functions are allocated, how integration is achieved, and how governance operates across the development. On the left is One North's land use. In the middle, the original 2003 master plan by Zaha Hadid Architects. And on the right, the district outline with our case study subsites and the neighboring areas we used as control cases. Here you see isometric views of the building clusters we studied in detail, allowing us to link form, density, and performance. And this slide highlights examples of the biophilic and bioclimatic architecture within One North, central to its environmental and social performance. For One North, we asked, spatial, how does it form, how does its form and integration compare with earlier business parks? Environmental, how effective are its strategies for thermal comfort, biodiversity, and ecological connectivity? Social, to what extent does it foster vibrancy, livability, and community identity? For policy, what governance arrangements enabled or constrained its development? And for comparative, what lessons does it hold for other tropical cities? So in the following, I will show you just a selection of our analytic work to illustrate methods, but because of time, I cannot go into detail here. Again, the exhibition and publications provide a fuller picture. So again, for spatial analysis, we use space syntax and GIS to map connectivity, land use mix, and integration with surrounding neighborhoods. This was complemented by people counting experiments and spatial visual analysis, giving us insights into both flows and perception at the human scale. So these are just some examples. I see we're a little behind here with the slides. Yes, these are some examples of the analytic illustrations that were produced over the course of our study. So I will just click through them quickly. And again, you find all of this in our publications. As for environmental performance of the district, we conducted mobile microclimate surveys across the district, added shade mapping, and ran CFD simulations. This provided a very fine-grained picture of how form and greenery affect heat exposure. For ecological performance, we carried out biodiversity surveys and worked with NParks data sets to evaluate ecological connectivity, moving beyond ornamental greenery to understand ecological function. In the social and economic performance work packages, we conducted our analysis through surveys, interviews, and GPS-based mobility analysis. We studied vibrancy, accessibility, and community formation. In terms of policy and governance, we reviewed planning documents from URA, JTC, and NParks, and conducted expert interviews, allowing us to trace the instruments, negotiations, and coordination that made integration possible. For policy and governance, we reviewed again various documents, and already a big thank you to some of the agencies that are present here today. That was very helpful for the work that we did. So let me quickly go to the findings again. We're pressed for time here. In terms of spatial integration, compared with Science Park 1 and 2 and Cambridge that served as our control sites, One North shows far greater land use mix with housing, workplaces, and amenities all within walking distance. It has far better transit access. I'm sorry, I'm behind here, yeah. Served by 2 MRT stations as well as connected bus routes. And it achieves higher walkability with finer grained pedestrian networks. This is the first time we've been able to quantify at this scale how a tropical innovation district performs compared to earlier models. The results confirm really what we think is a paradigm shift. For environmental performance, our microclimate surveys demonstrated quantitatively how tree planting and bioclimatic design reduce ambient temperatures across One North's public spaces, in some cases lowering heat stress by up to 2 to 3 degrees Celsius compared to the control cases that we studied. Biodiversity surveys confirmed richer species presence along ecological corridors than in earlier business parks. Remote sensing confirmed higher green coverage ratios, marking a deliberate move from ornamental planting to functional ecological networks. Together, these findings show how integrated design can measurably mitigate heat stress and support biodiversity in the tropics. For social vibrancy, our surveys showed that users value the mix of amenities, green spaces, and accessibility. Both residents and workers rated One North higher than earlier science parks in terms of vibrancy and identity. Our observations showed public spaces remained active throughout the day and the evening throughout the week. Most importantly, shaded and walkable streets directly correlated with higher levels of interaction, showing how spatial and environmental integration translate into social vibrancy. For policy, I think there are 3 key lessons that we want to share here today. No, it's okay, it's okay. Cross-agency collaboration. JTC, URA, and NParks work together, but only through persistent negotiation through economic, environmental, and social objectives. In terms of time horizons, success required a 20-year planning horizon. Shorter cycles would have undermined the integration. And learning by doing. One North really very much served as a testbed. Lessons from such as ecological corridors have since been mainstreamed into Singapore's city in nature strategy. This shows that institutional innovation was as important as design innovation. In terms of comparative insights, like One North, like King's Cross and Zuidas, the European cases that we studied, One North achieves integration of uses and vibrancies, but under much tougher tropical climate conditions. Unlike Quayside in Toronto, which remains largely conceptual at this stage, One North provides a lived operational benchmark. So in short, this makes One North not just a Singapore case, but a global benchmark for tropical urbanism. Before I close, let me highlight the wider achievements of the research. In May, we launched our book, Dense and Green Urban Development, at the Venice Architecture Biennale. So that book, maybe some of you have seen it already in the exhibition yesterday. We also have some copies here if you're interested in the next break. It features our Singapore case studies, of course, including One North, alongside our international cases. Our work is currently featured in the Singapore Pavilion and the Biennale Book Project at the James Sterling Pavilion. It is also part of the Time, Space, Existence exhibition at Palazzo Mora. And beyond this, our team has published numerous journal articles and conference papers and supported doctoral research, including a thesis successfully defended just last week at SUTD. We will also showcase our work in the upcoming Singapore Design Week at the Design for Care event. So, in sum, these outcomes show how both the rigor of our work and that there is international resonance for the output that we have produced. Looking forward, so what's next? At the Future Cities Lab, we see projects like One North as important experiments shaping the cities of the future, but challenges remain. How to maintain affordability and inclusivity, how to adapt as demographics, technologies, and climate evolve, These questions point directly, of course, to the next phase, FCL4, where the tools and lessons from One North will inform new frameworks for greener, healthier, and more inclusive urban futures. So to conclude, our research shows that dense tropical innovation districts like One North can achieve measurable gains in integration, thermal comfort, biodiversity, and vibrancy, but only when supported by long-term coordinated planning. For Singapore, One North is a reference point for future development. For the world, it is an important case for sustainable tropical cities. At the Future Cities Lab, we are committed to carrying these lessons forward from proof of concept to scalable strategies. Finally, let me acknowledge the excellent people who made this work possible. The dense and green cities research teams in Singapore and Zurich, whose collaboration was central to the project. Our government partners, URA, HDB, NParks, and JTC, as well as CLC, who engage closely with the research and its applications, and our many industry collaborators, both local and international, including leading design and planning practices. This has truly been a collective effort across disciplines, agencies, and institutions. And of course, I'm deeply grateful to all who have contributed. Thank you.
Thank you, Professor Schoffer. We will now quickly move on to our last presentation of this particular cluster, urban biocycles, mycelium digitalization, and I hand it over to Dr. Deepak Sharma and Dr. Jia Heng.
Everybody. It is mine and my colleague Dr. Deepak Sharma's pleasure to represent the Urban Biocycles Mycelium Digitalization module to present a summary of the research that we have conducted under the FCL Global Program, not just here in Singapore, but also in Zurich and Germany as well. So where do we fit in the overarching idea of developing future cities? Here, we are talking about what literally makes a building, its construction materials. The building industry accounts to nearly half of global CO2 emissions, resource utilized, waste generated, and energy consumed, respectively. And the economies of most building materials are also linear, where they are immediately disposed at the end of their life cycle, thus filling up our landfills and incinerators. So to ensure that we can develop our future cities sustainably, we need to explore the use of sustainable and renewable materials that has a circular economy into the built environment, where instead of going to the grave at the end of its useful life, they can be further used to create new materials. And the material in the case of our research is mycelium-based composites. Mycelium-based composites are sustainable biocomposites where, depending on its density, it can be seen as greener alternatives to lighter construction materials such as polystyrene, which is normally used for insulation, or to denser particle boards that's used for more structural applications. This composite consists of two main components, first of which is the mycelium, which is the vegetative part of the fungus, and the woody substrate. So firstly is the mycelium. So when a fungus grows, micrometer-sized filaments known as hyphae, of which a network of which is called the mycelium, will grow and extend throughout the substrate, and in the process, they bind the loose fibers together. And as such, in this case, they act as natural binders without the need of additional glue or chemical additives. The mycelium also helps to contribute to the mechanical strength, the acoustic and thermal properties of the overall composite. Examples that we have used in our research include the oyster mushroom, scientific name Pleurotus austriatus, or the Lingian mushroom, Ganoderma lucidum. While both serve their purpose well as natural binders, as how all organisms are in nature, different species will have their variations. So like for example, Pleurotus, they're more like explorers. They like to reach out and spread everywhere, across narrow gaps and into the air. Ganoderma, on the other hand, they're more like exploiters. They choose to conform and stay put once they have colonized an area. And as such, you can see the underlying structure which they are colonized on more clearly and distinctly. The second component is the substrate, and the choice of which depends on regionally available organic waste streams. Examples in Europe will include nettle, rapeseed straw, and hemp, whereas in the Southeast Asia region, we will have bamboo and rice husks. And the end result of incorporating this regionally available organic waste streams into the process would be location-specific circular material cycles. So the choice of substrate matters and can create composites that serve different purposes in the built environment, since individual particle size and type of substrate will affect how the mycelium grows around and inside the composite and how it behaves when it's deformed. So for example, one key difference between hemp fibers and hemp shavings is the particle size. And you can see the resulting composite here deforms differently when you compress them. Next will be the fabrication strategies that we have employed to fabricate these mycelium-based composites. So firstly, to complement our fabrication strategies, we have designed controlled environments of various scales, from large clean rooms to individual incubators, and each of which keeps other microorganisms out, which may compete or interfere with the mycelium growth when it's at its most vulnerable during fabrication. And in the case of the incubator, it allows for parameters such as temperature and humidity to be controlled for optimal mycelium growth. Across the three different groups in our module, we have employed different fabrication methods to create mycelium-based composites of various shapes and functions. First, on the leftmost column would be through the use of molds. Here, the composite will conform to the shape of the mold used, which includes simple shapes like cubes, to complex ones such as textured tiles, which are bio-inspired by the elephant skin. For the center column, we will have mold-free approaches, where we have grown mycelium on hemp ropes, which can be weaved or shaped to form complex structures prior to inoculation. Another example is through the use of textiles, which can be tensioned to the desired geometry, enabling highly adaptable and performative biocomposites. And lastly is additive manufacturing, an example of which is 3D printing, where free-form structures can be fabricated from the ground up using a wood-based ink that is sufficiently rigid and is conducive for mycelium growth. And all three fabrication strategies that you see here are scalable, where we're able to fabricate structures from as small as millimeters in scale up to meters in scale. And the fabrication process does not stop there, where through the process of heat pressing, we can further use it to create dense boards. And this process, when we apply heat and pressure to different extents, we can convert lightweight composites, we can densify them to various extents to form denser materials. And this process of creating dense mycelium-based composites is also scalable to the order of meters as well.
Thank you, Jehang. Now coming to the functional properties and the environmental impact of mycelium composites. So we already, like Jihang already mentioned, that the mycelium already have thermal insulation properties, fire resistant properties, even the water resistant properties. But these properties can be further engineered by the design of the substrate. So this is one of the example of how we design the substrate and which control the properties. These are called textured tiles. Because of this textured, the overall thermal response of this tile significantly improves. These tiles are actually inspired from elephant skin. So you see that elephant can live comfortably in hot and humid climate condition. It's because of this wrinkled skin which retain water, and during the evaporation it cools the body of all elephants. We adapted the same concept in our mycelium tiles, and because of this texture tiles we were able to improve the thermal response from 20 to 75% as compared to the plain textile or plain tiles. We have also installed these large scale tiles at NTU. The goal here is to understand their weathering for long term duration, and also to gauge the public perception, like how they feel when they see this tile, whether they hope to see this type of tiles in their home someday. Now coming to the scaffolds, we can also improve the mechanical properties, because like mentioned before, the mechanical properties of the mycelium composites are not very good, and they cannot be directly used in the construction unless we hot press them. But we can use stiff scaffolds. Scaffold provides the mechanical strength, and the addition and growth of mycelium improve the water resistant properties, thermal insulation. It can also improve the IR insulation properties. You can see the IR image here. It also improves the fire resistant properties. You can see the comparison between the fire spread in with mycelium sample and without mycelium sample. So what we observed from this study is that the growth of the mycelium is actually dependent on the design of the scaffold or the substrate. So to utilize this concept, we built this small mycelium house called myso house, which has 4 walls, all has 4 different design. Because the different design, mycelium growth is different. And in this myso house, we were able to maintain a warmer temperature and colder temperature without any external heating or cooling, just because of the mycelium and the designs. Coming to the environmental impact of to the construction sectors, here we see the low density mycelium composite. The goal here is to study whether we can use this mycelium composite for multiple cycles. So on the right hand side, you can see our circular process. It started with the growth of the substrate, then uses, but at the end, if you can instead of just disposing this mycelium composite, we can regrow it. And on the left hand side, you can see that the mycelium composite for grown for 3 consecutive cycles. Means instead of just throwing the mycelium composite after one use, we can regrow this, which is more renewable and more sustainable. Now coming to the more on circular design front, we also model this modular construction approach, which is a mixed density mycelium panels. It has 3 components: the high density mycelium panels, which is the load bearing panel, and then there is a low density mycelium panel, which improves the thermal insulation and the sound absorption properties. And together they are binded with the help of mycelium itself. So everything is organic. There is no synthetic component in here. And at the end of life, you can just dismount these things or you can just even regrow this thing, and completely sustainable. For the public outreach, we have been organizing some symposium and exhibition in Zurich and Singapore. The goal here is to gauge the public perception, get their feedback, to get better understanding, like how people feel about the mycelium composites. We also organize workshop at FCL and Tamashek Polytechnics. The participant includes students from the different institutes, public and FCL members. The goal again here is to share our knowledge of mycelium composite and get the feedback. The general response that we get from the participant is they were excited to know more about the mycelium. They were ready to use mycelium in their homes, on their life. Uh, and they didn't know much about the mycelium before the workshops, and also they were a little worried about the allergies from the mycelium spores and all. During this exhibition, we had the opportunities to interact with policymaker, even the member of parliament. We have been publishing a lot. These are some of the publication for a wider range of audience, specified to engineers, scientific researchers, even the policymaker. Of course, none of this work have been completed without the effort and contribution of our team of researcher and invigilator from NTU, KIT, and Zurich. At last, I would like to acknowledge our collaborators, past team members, current team members, and group of undergrad students. Thank you.
Concludes the presentations from our researchers. So we are now able to open up for a discussion session. So may I please invite a representative from each of the presenters to come up on stage, and then we can take questions from our audience. We also have Arno online. Hi, Arno, can you hear us? Yes, and Francis is also here. So, Arno, can you hear us? Is it clear? Okay. I think Arno is nodding, so it means it's all okay. Thank you, Arno. Thank you, everybody, for your insightful and very concise presentations, because we had to keep the presentations short and sweet so that we can have a lot more opportunity to discuss and talk about it and also address some of the burning questions which the audience may be having. Maybe before I open it to our audience to ask questions, may I just start with one very generic question to all our presenters? Um, what we presented today is actually a journey over the past 4 years, right? Of all the work which we have done, where we started our approaches, we have also transformed the approaches, the methods. Maybe we had to go back and forth towards what we started with, right? So, would you all, maybe each of you, could share some reflections on this journey? The challenges that you identified in the beginning or through the process, also some innovative approaches which came out of those challenges, which eventually led to the impacts or the insights which you arrived at. I hope it's not too wordy, but it's more on just trying to understand your own journey and the reflections on this. So there's no particular order, but we can start from Francis or Francis or Arno. Would you like to start? Since you're not here, so you have been arrowed to be the first one.
Okay, that's the sake of people online. I understand. Can you hear me? Yes. Yeah, thank you very much. No, it was a very interesting journey on many ends. First of all, as always, when you work interdisciplinary, it is all about learning about the perspectives and the scopes and also the methods of the different teams involved. For us, that was a huge learning. For example, connecting to the people that do data science, such as Francis, and mobility studies. And already very early on, we were able to connect this kind of energy-based research that we do with mobility research, also in terms of methodology. And I think that was very inspiring from both ends. And then, of course, as the research grew, reaching out and interacting with different stakeholders in Singapore and in Zurich, I'm learning from them. We had two roundtable discussions, which were really, really helpful with Singaporean agencies and industry, and that shaped our research and our perspective of questions quite heavily. Learning from the other end, so to say, and that directly infused into the further development of methodologies, for example, on new tool sets, but also on questions then that were surveyed by through studies directly. We were able to pose questions to, for example, real estate developers. So it was kind of a back and forth between stakeholders, pitching ideas and results, and learning from them in the back end. And I think that kept us a very nice cycle throughout the project.
Thank you, Arno. Francis, would you like to add something?
Maybe I add on to that. And for me personally, it was a great adventure and journey. It was a multidisciplined. I'm from data science. I know it's architecture, and we took a while to communicate and understand each other language a bit and what the stakeholders wanted. And the international exposure was very, very good. We brought our staff over and see Arnold's lab was amazing. The sun, the size of it, for testing the PV, I couldn't imagine something like that. And he could do it in Zurich. I'm not sure about Singapore. The exposure and really Arnold's guidance in bringing the people together in different aspects of the project. I really treasured that, and my team really treasured that very, very much. Thanks.
Thank you, Francis. So, Peter, would you like to go next?
Yes. I think reflecting on the past 4 or even longer years, because of course you also write proposals, etc. Similarly, there is an aspect of understanding each other and understanding the target audience. I think for our module, there was a clear shared understanding in the importance. There might be differences in methods, but this importance has certain implications. It is in some way also the reasoning or the typical storylines have a circular property to it. So in that sense, part of our work was also building, let's say, a shared conceptualization, but also how to bring that outward. And I think in many of our projects, but in Circular Future Cities specifically, there's of course like a strong normative angle, as also yesterday Sue was pointing out, that is important, that is a driving factor. But also these norms might be different within the group, but also you need to communicate this clearly. So in that sense, one of the things we learned was also to, for example, bring our message more clearly, but also understand how, even though we understood the goal very clearly, right, as a group, there were still differences or nuances that we kind of had to bring together in one, underlying conceptualization that helped us go forward. That was a very interesting process. It's not a direct outcome. It's not, you see evidence of this in how the work progresses, but of course it's something that underlies the work rather than something that is directly visible. Nevertheless, it's an important process as part of this kind of interdisciplinary research.
Thank you, Peter. Thomas, would you?
Sure. I'll be happy to. I think I can echo many of the things that have been said by my colleagues already. It is always a challenge to work with an interdisciplinary team. You probably got the sense from the Dense and Green Cities. Within the interdisciplinarity of FCL, Dense and Green in itself is so interdisciplinary, right? So as a team, you have to establish the basis, you have to establish a language that actually we all make use of each other and we all have different aspects to contribute to a very large and ambitious question, which is what might future districts look like? What can we do better about them? But I want to highlight another aspect that came more towards the later part of our research, which is how do we, now that we did the science, how do we actually translate this and communicate this to policymakers? And that certainly was also driven by the discussions that I have in my other role as here the director of FCL Global in Singapore, together with actually my co-PI, of course, in Dense and Green Cities, Sasha Menz, and Arno, who spoke earlier, which are about the next phase of the program, but also to show how the impact of the current phase of the program can be communicated. And in this context, I want to highlight the effort to translate some of the science, some of the findings that we have had into policies, right? So policy papers that we can share then with the policy relevant stakeholders in Singapore, be it at the CLC, be it at the agencies. So in a way, it is another layer of effort that we have to put in, that we do not remain on the level of the journal papers and book publications and exhibitions, which of course we all like and enjoy, but to demonstrate that the research that we do can have real impact and really inform the future of urban planning and urban design. So I'll leave it there for the moment.
Thank you. And Jaheng.
Yes. I think for our case for urban biocycles, we do share the same sentiments as well, where This is really a huge multidisciplinary project where even in our group we have material scientists, we have engineers, we have architects, and we even collaborate with designers and even startups. So each one of us, we will have our own different takes on what mycelium is, or what mycelium-based composites is, what are our aspirations, what do we hope to achieve from this. And so there are a lot of goals, and just trying to get them all together and to achieve each of them is really one big thing which I was kind of realized, because even for me personally, just working in just a field of engineering, I only have these certain goals in mind. But look at how architects think, look at how designers think. It's very interesting to see that in some cases our goals align, in some cases it can even expand further to bring mycelium-based composites even to a commercial setting. And not to mention also our communication with stakeholders as well, not just the policymakers, not just the industry experts, but even members of the public as well. It's also quite satisfying just to be able to educate to them about mycelium-based composites, what they are, and how they can bring a sustainable impact to our built environment as well. And also, I'm not sure I said it before, but also being able to hear what are their needs, what do they hope to achieve from mycelium-based composites as well. More specifically into research, I think what kind of interests us the most, even in our research, is really what the innovative ways where we could take towards the two components which I mentioned, the mycelium and the substrates. Like for the fungi, it is a living organism, so it's very interesting to see what we can do to try in a way to control how it behaves, or whether we could make it grow to what we want to grow. Like some of the examples, we were able to get it to grow on metals, on plastics. We could even control the amount of nutrients to change how it grows as well. So those were the interesting things that we could see. And even for the substrates as well, like the research carried out by my colleague Dr. Deepa, we were able to control how the substrate is underneath it, and then that could also affect the overall composite as a whole.
Thank you. Interesting. I mean, I think it kind of is very clear how we all have kind of grown into our own individual research over these last 4 years or 5 years. I just to also highlight, we have many of the researchers who are involved in these projects also sitting in this room. So if at any point of time you feel that there's something you would like to share on any of the points or any of the questions, please feel free to raise your hand and participate, because this is not really about only the 4 or 5 of us talking. It's actually everybody's work. So please feel free to participate and share any thoughts which you may have. I can continue to ask questions, but before that, I also want to know if there are any questions from the floor first while we have our conversation ongoing. May I please request if you could give us your name and the institute or association you're from, so that we can take note of your queries as well. Yeah.
Hi, good morning, everyone. I'm Emily, and I'm from SILA, Singapore Institute of Landscape Architects. So I would like to know, Dr. Jia Hing, about what other vegetative species have you explored before the two fungus? Thank you.
I think I can share first, and maybe my colleagues in the audience can also give their input as well. I think from my experience, even for our group here in Singapore, I think those were the two that we are looking at for Pleurotus and Ganoderma. I believe that our colleagues in Zurich, they have also looked at another species known as termites, which is also another type of fungus, which is able to form filamentous fungus as well. Yes.
Before we go to the next question, is anyone from your research team wanting to share more on that question?
So if you are referring to more mycelium species, what we are focusing on is mainly the wood decaying mushrooms, like those that can digest fibers and lignins without the support of other microorganisms. So what we have been looking for mainly is polyphorous mushrooms, like two examples. That is what we have been working on. But of course, there are many species that we haven't explored. That's what we're working at the moment. So our collaborations or working doesn't end here, although we are not part of the next chapter of FCL, but we would definitely continue working on this.
Thank you.
Hi, my name's Cassidy. I'm a researcher of concrete decarbonization, well, concrete and cement, and I'm looking at my own research looks at innovations coming out of Singapore. So I actually have many burning questions, but I'll ask just one. Um, so two things that I've kind of learned through my research is that Singapore is, at the same time that it's trying to become an innovation economy, it's also a very risk averse decision making in terms of actually adopting those innovations. So I'm curious to hear. I found all of your presentations extremely interesting, and it's clearly very cutting edge research. But how would you evaluate Singapore's appetite to adopt your recommendations or some of the innovations that come out of your research? Thank you.
Thank you so much. I think that's the biggest question which everybody has in their mind. So maybe Peter, do you want to start first?
Okay. I think in a way it's because you refer to appetite. It also depends on the type of restaurant you are and the type of food you're serving. So there's a conversation process and a negotiation process on how applicable are certain things, what is of interest for who at what time. So in that sense, I don't think there's a singular answer to your question. And in that sense, it depends. What, for example, in terms of circular economy in construction, we've noticed is basically over the span of the project, a very quick ramp up in interest and research support in this topic that was not at that level when we were writing the proposal, basically. So in that sense, topics can quickly emerge or get a new emphasis. Or in that sense, it's a dynamic landscape. It's a collaborative negotiation process.
Arno, would you want to address on this point as well? I know that there has been a lot of dialogues on this aspect within your module as well.
Yes, that's true. So I think that's a very interesting question. Actually, we circled quite a bit around this question, as on one hand, photovoltaics in Singapore is well established on the rooftops. And what is quite interesting for the learning was there was an existing model how things would connect. So on rooftop PV, for example, there is a business model. It's a win-win-win situation for everyone involved, and that is clearly an enabler to scale up these type of technologies. And when we came to BAPV, which is photovoltaics applied on other services and more deeply integrated into buildings, these clear models were missing. So there was a lot of questions, there was uncertainty, and there was not. The field was rather open, and in this situation, we had the impression that people were more awaiting how things would develop, and also look to forerunners such as test cases by the agencies until they would adopt these type of approaches and technologies. So we saw both an embracing and a strong interest on innovation, and once basically the nitty gritty has been solved, a fast uptake, and then on the other hand, maybe a certain, I would say, a time dependency until those critical questions, for example, business models and also policy guidance and policy interventions were solved.
Thank you, Arno. Anything from the mycelium adoption as well? Because I think that's another, when you talk of innovation, I do agree that I think in Singapore, we do see a lot of opportunities which are backed by the stakeholders in terms of exploring and, looking into the future possibilities. So risk appetite, yeah, there is something, as Peter mentioned, it is relative, right? Depending on what aspect, at what point of time, and what's your application pace, how fast you need to apply. But I think there is still a lot of backing from many stakeholders in terms of innovation, in terms of looking at possibilities and looking at future solutions. So I think mycelium is another example where you are looking at such innovation, which is a little ahead of time. In a way, I don't think the market is ready. I don't think the industry is ready to produce such products yet. But I think the research actually proves that it has huge potential, right?
I think I do agree with what you mentioned, Sri. Yes, I do agree that Singapore is risk averse, but at the same time, they are also looking for innovative ways to solve some of the many current issues that they are facing, even in this tiny island state. I think one of the recent ones that is of the topic of dialogue, which is about cooling Singapore. How do we help to ensure that Singapore will have that thermal comfort even in the coming years due to global warming and climate change? And I think like what Sri has mentioned, it's a lot about and also it's also a lot about like knowing what are their specific needs and also being able to engage in dialogue with many different stakeholders, different parties, and also to be able to build up their confidence through the findings of our research, through optimization, fine tuning, and even also just being able to meet their needs, assure them that yes, this is safe, this can indeed address, if not all, most of the issues, and also be able to set up the infrastructure as well.
Thank you, Jing. I think, Professor, you were talking about policy level innovations as well.
Yeah, not just policy. I mean, the question was, is there appetite, right? I would say there is tremendous appetite for the work that we do here. I mean, the fact that we exist is already an expression of that appetite, right? And we have been around 15 years now. We're in the third phase of our program. Hopefully, there will be a fourth. And this is longer than any other program at Create. So clearly, there's appetite, right? I mean, Singapore is in a very unique position to drive innovation in urban planning, urban design. And by this time, as you all know, we are not the only players, right? In Singapore, there are other initiatives in the city's realm. There's also research done at the agencies. Urbex is a great example, Center of Excellence, that has been in place for a couple of years now at the URA that we work closely with. So clearly, there is a wish to explore what are models for future cities, and that crosses all the scales. That goes from the material scale all the way to the district scale. So in this round, we are probably representing the largest scale. So there are big developments coming up in Singapore. There's the new Southern Waterfront. There's the Long Island project. So these are massive developments for which everyone will also look at research and some of the things that we have produced here. I would hope that we can provide some insights and also help shape that future of Singapore, but not only Singapore, of course. We have a global in our name, and we take that very serious. There are lessons to be learned also from other places in the world. But we also have to acknowledge that Singapore currently is a great laboratory because the pressure is so high to develop new concepts, new strategies, new designs for a kind of a compact, high density city in the tropics, right? And urban growth will be in these areas, in the tropical areas, primarily, as we heard yesterday. So I think in that respect, there is no doubt, right? I mean, there should be dish after dish, right? Of course, it should be well cooked. It should be well cooked, right, and not raw. So that's where the policy comes in. So I think there's a very important step we need to take to translate the more scientific insights also in policy recommendations and discuss them with our partners in government and think tanks and so on.
Yeah.
Industry. Those two words.
Francis.
I think recently there has been a lot of workshops together with the agencies. I think when you start off with that and then you know what your touch points are, that becomes stronger. And then there's a bigger chance of a bite. And yes, everyone is a little bit conservative because Singapore is very small, and there's only so much experiments we can do, So once you get a touch points with the agencies, they have their research labs there as well, and that combine the forces together, then we do bigger things together, and that's how I see moving forward. And you all have already done that. We have already a number of workshops with a number of agencies, and I see that as a very positive move towards working with agencies as our partners, as stakeholders, for future city labs.
Yes, sure.
I just want to add to this. I mean, the way I see initiatives like the Future Cities Lab is also to ask more fundamental questions, right, about the future of cities. And that can be so nicely complemented by some of the big research programs that we have in Singapore that are run by the agencies like the Cities of Tomorrow, which are more kind of near site, right? And of course, we also do that, and we hope that the work that we do informs those as well. We are actually fortunate. We just received one of the COT grants. So you see clearly our research means something to Singapore. But at the same time, I think there's a necessity for a place like FCL to ask more fundamental questions about what future cities should be like.
Thank you.
Thank you. Hello, I'm Yuning. I'm from National Parks Board, but I also sit on the advisory committee for the FCL Global. So thanks for the presentations. It's good to see the research come so far since the last midterm review. One of the questions for the CFC project is the last time we also asked this question about authorities and the resonance with agencies, whether your project has found resonance. So I didn't know whether that's been followed through, and I didn't quite hear it during the very short presentation that you were able to give. And I also have wondering about the kind of catalyst you talked about for the emergence of the circular economy for the EC. And this is about the shifting kind of governance you spoke about, as well as the enabling economic agents. So I wonder if you can elaborate a little bit on that and talk about what shape or form that should take, and how do you and where do you think we are in the process, or the project is in the process of securing that type of support. And likewise for the mycelium project as well, whether you've gone on to develop case studies on how the usage of the materials should come about, and to what extent can it replace existing materials in a very typical development, say HDB or whatnot. Yeah, thanks.
So, Peter, you want to go first?
Yeah. Concretely about support from the authorities. Well, I said concretely, but perhaps well, I won't be too concrete. But we've been having a long-standing conversation with the Centre for Livable Cities. Also, they're part of our advisory board. This has recently it's been going into promising directions. So I won't go more concrete than that at this point in time. In terms of these catalysts, as we've mentioned, in terms of how do you go from research to impact in policy or industry, it relates to having solutions, but also pieces of technology that are more tangible, that go into something. So in terms of the emergent support there is mostly in terms of finding a particular application or particular niche in terms of the transition thinking or transition management perspective to build on in terms of stimulating this circular economy in construction. So developing an application that advises design strategies and methods to evaluate these is one way of supporting from a design perspective, for example. From a policy perspective, the GHG app that we've made brings these things together, because typically as researchers, we produce very intricate knowledge, and there's detail and nuance, and that's all nice, but you also need to provide a way to kind of cut through it in order to recommend particular approaches or technologies. So in that sense, it's around such aspects that the circular economy in construction can be strengthened. Of course, the research itself is not about seeing how that emergence happens. Of course, we want to do that going forward, of course, right? But that is, that's a process and an experimentation with many partners, right? In that sense, the technological innovations we've developed should be seen as a seed and a starting point to such a story. In terms of the actors, I think it is important also that the research highlights the importance of that in a systemic narrative. A lot of our work originally comes from a kind of construction level, but of course, in a singular building site, there is no economy. It's only when these things spread. And so by explicitly looking at technologies that are about the trading of information or the storage of information or the categorization as to which type of built environment professional is involved in a certain design or evaluation, we can make much more sense of those agents. But again, the emergence as a property of the whole complexity of the system is, of course, something that would happen through particular pilot studies or concepts, things we want to explore, things we're building towards. In that sense, the aim was not to, let's say, suggest what are the exact catalysts, because you need to, you study a catalyst by looking at it in the system, basically. So that is the next step.
So for the urban biocycles, I understand that there were two questions, so I'll go with the first. With regards to case studies, we are currently looking at seeing how our textured tiles can be used in a more practical setting, where currently in NTU, in front of the entrance of the School of Mechanical and Aerospace Engineering, we have collaborated with BioC and Mykelio to set up a array of these tiles, and these are large, by the way. It's about 30 centimeter tiles, and we have just placed them not just to gain public perception, but also just to see how well these tiles last in a semi-interior state. Semi-interior meaning that it's still under a roof, but it's exposed to some of the elements like humidity, and we want to see how well they last over the period of months, maybe even up to a year, and even to see how they behave as well in providing passive cooling even in the surrounding area as well. So that is one of the case studies that we have. And as well as with regards to communication with like government bodies on like adoption and all that. I think this moment is more into the exploration state, like what can we do with this composites, what can we do with the tiles. But just happy to share that over the past 2 years, we have been communicating with the URA. They have expressed an interest in our textured tiles, and we were able to showcase these tiles even during one of the exhibitions that they organized, Cooling Singapore in 2023. And even we've even collaborated with them, where they have showed their tiles at their booths during last year's World City Summit as well. So it shows that we are in communication with some of the governing bodies in Singapore as well.
Thank you for the sharing this morning. I think it's really very solid work that has been done. My question is more about how do you see yourself in terms of capability building uh, with our public agencies, because I think that if you do more of this along the way of the research, you could actually build the appetite among our public agencies to adopt some of these solutions too, right? I mean, if I understand these things more and how they can be applied, or even some of the tools you've been using along the way, it could create a more receptive kind of audience in terms of adopting the solutions and what to do. I mean, I think earlier in the week there was a lot of discussion that the whole adoption and deployment of solution is the thing in itself, a process in itself. And if this could be built into your research projects and part of the capability building along the pathway towards the solution, do you think this could be one way to build in the appetite to deploy these solutions in Singapore?
Take this.
Maybe I take this. Thanks, Limin. I think it's a great question. Obviously, you're aware of, as our knowledge partner, of the many efforts that we do make, but this is evolving, and we're constantly exploring other ways to, in a way, share the knowledge that we produce at FCL. I want to share one example that is under me, but I'm sure the colleagues could also share examples from their own modules. So we currently have a designer, an architect from LTA in our team. So her PhD is financed by LTA. And it is the idea to expose her to the work that we do at Dense and Green Cities, but of course in the larger context also of the Future Cities Lab, and expose her to some of the methods and tools that we develop, right, in a more academically driven context, and that she then brings this back after she graduates into LTA. So I think it's things like this that can certainly make sure that there is a knowledge transfer, right? And she will certainly remember the things that she did with us as she moves forward in her journey as an architect in the Singapore government. I think my phone is breaking. So that I think is one, for me, is a really encouraging example beyond all the other things that we do, the outreach. We participate in the Science of Cities Symposium every year that CLC is organizing. But I also want to say it takes two to tango, right? I mean, we also need the invitation to do such things, right? And often they are kind of bottom up, like LTA. This is an initiative that we have. Some of the other modules might have similar initiatives, but there's always more we could do. And I would like to take this opportunity to also address some of the agency partners we have here with us today, to please, explore with us more ways that we can make sure that there is a knowledge transfer, that there are interesting ways that we can bring what we work on here into your daily practices.
Thanks a lot. In the spirit of this discussion, I think what I especially like about this panel is we get to write. It's the chemistry of materials, and it's so specific, and that's one thing. Secondly, there's a lot of maturity in the room in this work. There's 2 or 3 generations worth of study as well. So I think it directly applies in a way to the question about how do we move from first principle research into application. And it seemed to me that you've already been mentioning a couple of strategies. Of course, at the material level, the piloting, ETH has such a great tradition of studying materials in the real world and going from the lab into physical prototyping. And I love the tile examples that really jumped out, the one that your colleague presented, so that the elephant skin as a kind of performance dynamic material, evaporative material, you seem to be suggesting. And it seems to me we've got a lot of skill right on the panel that we could invent a kind of physical pilot for that takes it out of your lobby. Maybe there's some material passport. I'd be interested to know what a material passport approach would be to a kind of dynamic material like that, a performance-based material. Maybe stretching it too far, but if Arno or Martin were interested in the building integration of that, then we could design a pilot right in the room, and we could sign on the way out with some relevant agencies who are prepared to kind of host that pilot. A couple of sidebars to that. I know how incredibly difficult it is to do physical materials. There's safety issues. There's the land that has to sit on the materials. You're effectively building a kind of new building site But I do think for this particular cluster, it would be really innovative to try and develop a new way of translating lab-based research into the real world. But I love the elephant, and I think that's such an important piece of research.
Thank you, Stephen. Thank you. I think, yeah, Arno, is there anything you need to add?
No, I would, of course, totally sign up to that. I think that it will be very interesting to connect those different capabilities. And yes, I mean, as Stephen has mentioned, I think bringing things out of the lab into practice is extremely powerful. I mean, when we go into living labs, when we start realizing and applying things in a realistic setting, it immediately multiplies. It's very interesting. I mean, you can write a lot of papers until you have the traction of a physical demonstrator where people can look and feel and see how things work. So I would definitely subscribe to that.
Thank you, Anu. I think, yeah, we have a couple of more
Hello.
questions at the back. Yeah.
Okay, so, good morning, everyone. I'm Luciano Brina, a recent PhD candidate from Singapore University of Technology and Design. First of all, thanks for your presentations. It's very impressive amount of work, and Professor Hertwig's quite impressive as well, especially quite impressive. So, I'm currently developing a geospatial decision support system for landscape infrastructure planning and nature-based business modeling, using the Singapore Johor Special Economic Zone as testbed. And I'm currently exploring the possibilities of commercializing such platform. And one of the questions that being posed to me was that if whether me or eventually startup or my company or my institution would take legal responsibility of the outcomes, decisions that might be reified as buildings, projects, programs, and so on, that the provided information of such platform might yield when being employed by practitioners or stakeholders. So the point is, if I do so, I will put myself in a very, let's say, vulnerable situation. And in a way, if I not, then the practitioners wouldn't really have much incentive beyond information or curiosity to apply such a decision support system, because eventually, well, they will require consultants, specialists to have proper certifications. Now, the question will be, if you have ever faced this kind of situation or problem during the development of your platforms and your apps and support systems, and if so, how have you dealt with it? How did you frame your developments in a way that you provide valuable information to these stakeholders without compromising the integrity of your research unit or of yourself, essentially? In a way, this is a question not necessarily on legal aspect, but rather on a more conceptual and fundamental approach and how you frame your work in a way. Thanks.
It's a question that always is a part of a decision support system because, yeah, decisions have consequences, right? As academics, you typically release your platforms with particular caveats, or they have because of course we're not in the business of developing services, right? And so in that sense, research has certain scopes, has certain considerations, and in that sense, the types of applications that you see are, of course, they're intended to make research tangible, to give recommendations, but they're not a commercial service, and they come with particular. There's they have a level of promise that they provide. I think as this goes forward, that's also where these, the levels of certainty become more important as well. Typically, because it is one question, but again, it depends on the type of, let's say, decision support you're working on. If you're doing, for example, planning support for strategic exploration, your certainty level needs to be less high than if you're doing a public-facing kind of evaluation of something. So in that sense, it really depends. And in a way, the more certainty you need, the more the scope will reduce. That's the normal process of that. But yeah, I think the main line is that the academic outcomes come with a certain caveat in that sense, because it's not it's not in our business model. But I lost my butt. So Thomas,
Did you say you're from SUTD? Yes. Okay. So I think it's a good question. I would encourage you to, if you have something that you want to share with the world, or you have an invitation to contribute to a real world project, you shouldn't do this alone under any circumstances. Okay, because there are serious legal implications, as this is part of your question. So I would encourage you to have immediately a conversation with our Office of Industry Collaboration, as well as with our Office of Research, right? I mean, there are many examples in the short history of SUTD where we were able to contribute to major projects that build projects in the Singapore context, where our research did something that was very cutting edge but needed to be implemented, and we needed to be protected. So you cannot go out as a researcher or as a professor. You need the institution as a backup. And we have a whole legal team there. We have people with the right expertise. So that is what the institution is for. And I'm sure, I mean, what we have at SUTD, I'm sure also exists at all the other universities. So there is a mechanism in place. And maybe it's new to you because you're still a researcher, but there is a lot of support for that. And in fact, most universities welcome exactly this, right? Because these are projects where you can show we have direct impact, right? We can work with industry, we can work with government stakeholders, and so on. So there should be a lot of welcoming of your ideas and support.
Hi. Thanks for all the presentations. I have a question on circular economy. PhD year one student of Department of Architecture here. So I think circular economy is especially challenging because the circular itself addresses dynamics. And in Professor Peter's presentation, you've mapped material stocks. And what do you think about mapping flows and yields? Because take London and Singapore, for instance, we import agricultural products and we not likely to export them back. So the materials are not circulated back. And so do you think this dynamic problems is to be worked on as a representation model, or and it's like statistically can be managed? It's probably implied in your presentation that its next step is enabling economic agents. Would you like to elaborate on that?
thank you. The enabling of the agents, I think that was also part of my answer to Yuning. In terms of the modeling of flows, this is of course important, and it is dynamic, and it is something that is part of the cutting edge of what we need to explore. So specifically, the work package that I've been leading looks into what does design bring to the table in terms of the retention of value, because a lot of the work, I'm talking specifically about construction, of course, in terms of circular economy, a lot of the work deals with materials and resources in tonnages and volumes, but the value of buildings is more than tonnages and volumes, and the design is in the configuration of all these things. It's how we configure things that gives it its function, its value. that's an aspect that, for very understandable reasons, is often not encapsulated in, for example, the life cycle studies we do. But it is important. If a building has lasting value, it'll be used for longer, and hence there's that retention. So how do we look at the configurational aspects of what is being modeled, and how does that influence what we can do? So that we explored that from the perspective of recommending certain strategies or qualities, although they're actually dispositions, to link back to Sue's talk from yesterday. Typically, designerly ambitions and goals, they're dispositions. They're probabilities. They can happen or they cannot happen, and depending on the context in which you have a building, it might be adapted, even though it has a certain adaptable capacity. Those are properties that we can distill from how a building has been designed and constructed, and they influence this economy as well. So specifically, that is what we looked into. Can you hence give more of a sense of what could be done with a certain type of building or building design? Yes. Does that lead to a exact prediction or yield of what comes out? Not necessarily, but it gives a better indication. You can go into categories or margins of what is more likely to happen. But also, in a way, these strategies and these dispositions, like, is it flexible, is it adaptable, is it maintainable? Once you model them, you represent them more formally. These are properties you can also instill and plan in the built environment. Which parts need to be more adaptable or less adaptable, or longer or less long? Which floor level needs which kind of disposition, in that sense, in terms of the value retention that you expect, or the turnover rates and these kinds of things. And so designers work with these kinds of things, but of course you need explicit models to be able to do something with them in a more quantified sense. So hence it's part of this module research in terms of it's cutting edge in a way to represent that in a more quantified way.
Thanks. It's just wonderful to hear. I think Stephen used the word maturity of the projects. But I wanted to ask each of you, or any of you, if there were an opportunity to engage with health researchers, how, if at all, does your work lend itself to it? In other words, is the frontier of your work, in other words, predefined in a way that it's to go deeper into what you are already doing, or would there be opportunities for synergies with big other areas of research, like questions of health?
So who want to go first? I'm sure. Arno, do you want to, or Prof. Thomas?
I mean, health is a Oh, is it Arno? Okay, Arno, you go first.
Arno, you can go first.
Sorry.
Yeah.
Okay, there was a lag. Yeah, sure. I mean, I think especially health is a very interesting field we're trying to connect to. So, from our perspective, we've very often addressed questions of energy and emissions. It has become clear that, of course, what we see with climate change and the health implications of the built environment are as dramatic, if not even more. So, especially in our field now, in the next step, also in FCL4, we will connect to health and health research and questions of vulnerability. So I think our field that used to be more on technology is embracing questions of occupancy and human health. And I think that's a very exciting way, also because there's obviously very different questions in the room. So far, also in FCL3 and the previous stages, we looked primarily from a planning perspective, looking into buildings more in the infrastructure, the built environment as such, and now shifting the perspective towards the occupant, the city dweller. From a health perspective, I think that opens a lot of different questions that can potentially be very impactful.
Thank you, Arno. Yeah.
Yeah, I mean, of course, health is a very important component. I mean, we have been looking at this more under the umbrella of livability in the Dense and Green Cities project. But moving forward, there is probably a shift to well-being and health, and that also has to do with larger kind of national initiatives in Singapore. So definitely in, hopefully the next phase of our project, there will be a strong focus on those two aspects, health and well-being. This is also the outcome of our ongoing discussions with CLC, our knowledge partner, and I'm also happy to report that the Health Promotion Board of Singapore has approached us. They heard about our research. They are very interested in being part of this journey to define what future districts in Singapore and beyond might look like from a health perspective. And we're going to count on them as a kind of source of data for the next phase of our project. And we're also in parallel exploring a number of other cities of tomorrow grants that would require stakeholders like the Health Promotion Board as well as CLC. So I think it's an ongoing effort as far as our module is concerned. As Arno already mentioned, this will be one of the major kind of focus areas of the next phase of our program, and we are very much embedded in a larger national agenda to deal with health, also dealing with changing demographics. I mean, it's a rapidly aging society here in Singapore. So that has certain implications for the built environment. And as FCL, obviously, we want to be on the forefront of such important questions.
Thank you, Proximus. Any further points to add from? So yeah, okay, Jiaheng, yeah.
Yeah, I think with regards to our composites, with regards to health, I think it'd be good to see the inputs from the health researchers on more of like an assurance from them that our products are more or less safe to be used even in the built environment. I mean, make no mistake, even in our current research, what we are using are organic materials, things that are safe to handle. Even the fungi are generally regarded as safe. I mean, the evidence is that we have been working on it for 4 years and we are still alive. Yeah, but I think overall, getting the assurance that that yes, it is safe to be used in the general public can also improve on its reception even to the members of the public as well. And I think other aspects that I can think of at the moment would be how it improves, like, I mean, even the aesthetics alone can perhaps also improve the mental well-being of the members of the public as well. And that could be something that that health researchers can look on as well.
And if I can just add on to that aspect, I think we are not just waiting for the next phase to look at how we engage the research we do in FCL with health and health-related research. We are actually currently involved in a couple of integrated research projects across the different programs within SEC, with FHT, which is the Future Health Technologies, as well as the Future Resilient Systems researchers on projects where we are linking the health data with built environment data, because that's where I think the real gap is right now, because both of those data sets needs to talk to each other. So how do we geolocate the health data such that it can inform us on how we design the spaces where such studies and such data are currently being mapped. So there are two ongoing research in that particular realm already. And we do see that our future programs will probably have a similar synergy when it comes to engaging with the health-related or future technology of health narrative within SEC and also in Singapore. Yeah. So thank you so much.